So to demonstrate a transformation with functions, I'm going to be using an exponential equation. So this is the formula: y equals a b to the x, and b is just our base, x is our exponent. So our parent function is going to be y is equal to 2 to the x, and we see that here since this point is at its x value is 2, and that's just how our parent function looks. So for a vertical shift, what you need to do is move your parent function up or down by a certain amount of units. In this case, our vertical shift equation is going to be 2 to the x plus 3. That means that we're going to be shifting our function up by 3 points, which you can just count out. So it goes up 1, 2, 3 points from this point, and then from the other point it goes up 1, 2, and 3 points. So that's a vertical shift. And a horizontal shift is when you change something about your exponent. So in this case, we're going to be adding 4. So our graph is going to shift 4 units to the left. So when in our parent function, when x is equal to 0, y is equal to 1. For y to be equal to 1 in this equation, our x needs to be equal to negative 4. So our point would be negative 4, comma 1, which we graphed here. And then when our x is equal to 2, our y is equal to 4 in our parent function. And for our y to be equal to 4 in the parent function, our x needs to be equal to negative 2. So we just go over negative 2, and then we go up 4. And that is a horizontal shift. And you see in a horizontal shift in the parent function, they have the same asymptote, while the vertical shift in parent function have the same vertical asymptote, and this one has the same horizontal asymptote, to be specific. So just to clarify what a horizontal asymptote is, we see that, an asymptote is just a line that the function approaches. It can cross, but in this case it does not. So we see that our horizontal asymptote is at y equals 0, and then our vertical asymptote is at x is equal to 3 because it's approaching this line. So in order to turn our parent function in the pink here into our transformation in the orange, which is y equals negative 1 times 3 to the x plus 3, first we did the compression right here in this positive blue function. So you see that the parent function, it's compressed in the blue, and then you would multiply that by the negative 1 in order to flip it over the x-axis, aka a vertical reflection. So this compression was flipped over, and then you take your last step, which is plus 3, which means it is a vertical shift, but it's a vertical shift up because it's a positive 3. So we went up 3 points, 1, 2, 3 here, and then 3 points here as I marked, and this is your final transformation in the orange with dotted line. So I'm still trying to show a transformation when there's more than 2 steps to a transformation. So we started off with a parent function of 2 to the x, like in every problem, and we're going to end up with y equals 4 to the negative x plus 7. So what I did first was to show compression and how it works. Like I said, the greater the number, the more compressed it is. So we see the parent function 2 to the x next to the compression of 4 to the x. Then the next step was to create a negative exponent. So it's going to be 4 to the negative x to show that there is a horizontal reflection, which means a reflection over the y-axis. And then the last step was a horizontal shift. So we end up with our 4 to the negative x plus 7. So the function is moving over to the right 7, which I show with these dotted lines here. So over 7 spots on each of the points. And that is our compression, reflection, and horizontal shift. When dealing with multiple transformations, like in this equation, f of x equals negative 6 times 4 to the negative x minus 5 plus 6, what we see in our transformation is a compression because your a is being multiplied by your b, which makes a number a bigger number, and a bigger number results in a bigger, like a more compressed function. Also, this will result in a reflection over the x-axis, which is also a vertical reflection. This reflects our function over the horizontal y-axis. This negative 5 shifts our graph 5 units to the left, and then this positive 6 plus 6 shifts our graph 6 units up.